All right, our next speaker is actually bringing back a topic that was already briefly mentioned this morning by Enrico and during his talk, and we are going to look a little bit more in depth to the PSR-18 HTTP standard, HTTP client. All right, so without further ado, his name is David Buchmann. Yeah, and
all right. Hi, everyone. I hope you're still awake after 2 days of conference. So, last regular talk before the closing keynote about HTTP clients. A few words about me. My name is David Buchmann. I'm from Switzerland, working for a company called Leap. We're a web agency doing all kinds of web projects. And if you are interested in moving to Switzerland or living in Switzerland, we are hiring. Check out the jobs. So, oops, sorry. Who was around to remember what the difference between Guzzle and Guzzle HTTP/Guzzle is? So it was just a new major version, and when they released it, or before they released it, they realized like everybody's using Guzzle, and everybody who provides a library that gives you access to some service is using Guzzle, so they require Guzzle. But if you use like 3 different libraries because your application talks to many different services, each of those will require Guzzle, and if suddenly one needs the old version of Guzzle and the other one would need the new major version, there would be a problem. As you know, in PHP you cannot install the same code twice. Like in Node you can do that, it like wraps the whole internet into your folders, and you can somehow do that, but in PHP it's not common. The aim is that you have like one instance of each library. So what they ended up doing is create a new namespace and a new composer name for the new version so that you can install 2 versions of Guzzle in parallel. Which, in the end, the root cause for that problem, I'm not saying it was a bad solution at the time, but the actual problem is that all the libraries, all these clients that are around for any services, they had to depend on a specific client, on the specific HTTP client Guzzle. And that's what creates the problem, because these libraries usually don't really care much. Is it Guzzle version 5 or version 6 or 7, or it could be something else even. It doesn't really matter. All they want is be able to send requests and get back a response. So my personal situation was kind of the same. I was writing a library to talk with the Varnish HTTP cache to send in validation requests, and having written stuff before that had to send requests, I knew I don't want to use the PHP built-in curl functions, whatever. It's just not a nice modern way of doing web requests. So I was like, well, okay, so I have to use Guzzle, and then I realized this thing, and yeah, well, at the time, I ended up using Guzzle directly. But then came into contact with people who discussed about making some sort of interface for HTTP clients. And we came up with that name HTTP plug. And basically what it does, this project, is give you an interface how you would send a request and get back a response. And then we wrote adapters for all the major HTTP clients at the time, so Buzz and Guzzle and I think a couple of others. There was also a React adapter and whatnot that made all of these behave in a way that your application doesn't need to care which one it actually is. That worked out for me. So the version 2 of the HTTP cache client is now using that HD plug and not depending on any Guzzle or anything. But then we didn't stop there. Somebody came up with this, well, you know, there is the FrameworkInteroperability Group. And so basically the idea of that group is to be a pool of people from different PHP projects. There's like big frameworks, big CMSs, big other applications and libraries represented in this organization, and they agree together on standards, or standard recommendations. And the idea is that you get code that can work together better. And I'm sure that you're using some of it. For example, I guess these days everybody is using PSR-4. You put your PHP code in a way in the file system so that you don't have to require once at the beginning of your file to have a class available and stuff like that anymore. There is autoloading, but for autoloading to work, you need this standard so that the autoloader knows where to look for the file that defines your class. Most languages have that in the language. PHP didn't. And that was like one of the early PSR that everybody's using. It was part of what made Composer actually feasible and possible. Another one that many people use because it's very simple and clean is the logger interface, which just says, like, if you want to do logging and you don't want to bring your own logger, whatever, here is an interface, make your library require that interface, and then you can log. At the time when we discussed about this, there already was a PSR-7 about HTTP requests and responses. So the idea of that one was just defining how do you represent the request that you want to send or the request that you're receiving on a server, and how to represent the response that's coming back, and then also a URI interface to manipulate URLs without doing string and split and string pos and stuff like that. It was mainly done from a server-side perspective of the HTTP process, because PHP in the end is a server language. Most people will not run that on a client or something, so the main thing was like, well, we receive a request, we do stuff with it, and then we return a response. And if you're writing like the server side of a request, that's what you need. It's all you need. You will have your framework build the request object for you. You get that, you do stuff, you return a response, and the framework cares about how to make that go back to the client over HTTP. But if you're building the client side of the request, you need more than that, because you would have the request and you want to have a response for that, but there's no way in the code to make that happen. And there was even one more problem, because the request and response are interfaces, like all the FIG standards are defining interfaces, not implementations. It was, how would you even create a request if you're not given the request, like with the server side? You would, either you depend on a specific implementation and then you can do new, or there was this PSR-17 that defines how to, defines the factory interfaces to create these objects. And with this, you can give your code the factory, and the code can just create the object without needing to know what concrete implementation it is using. And the factory will give back the interface from PSR-7, so then you know how to interact with the request or with the response that you created. But then still, you need to be able to, sorry, that's just what I just said. PSR-17 also is about all the server-side things. So you have a server request factory, you have an uploaded file factory. One thing I'm not going to talk about much, but which is also important, is streams, because you will have requests where you want to upload data, and they took that separately, so there is a stream factory and a way how to make streams for web requests. So anyway, then we want to send this request and get back a response. And well, the whole PSR-18 basically is this slide. It is, well, the interface you have to the client is simple. It's just this, you give it a request and you expect back a response, or there is some exceptions it could throw. And at the core, that is all there is, but there's going to be a lot of implications, so we're not done yet. How would that look? So this would be some mock client library where I can say I want to get that product. So I'm building the URL, I'm building the request with the help of the factory, and then I'm using the client to send the request, get back a response. I should check the status code of the response. We'll come to that in a second. And then, like usually these days, if you're doing a nice client, a nice code, you want to return then a value object, a domain object, something that represents your data. So in projects that I work, we usually have like this actual HTTP layer, which is hidden with the PSR-18 interface. And then there is one layer that cares about talking to HTTP and gives back models that represent the data in an object and not have like raw JSON data or something all over the place in your application. Yeah, when you Google for PSR-18, at least in Switzerland, you end up with drills for some reason. But it's also this standard for the interface. So what we have is this client interface I showed, and then a couple of exception interfaces, so to have a defined thing that you can catch if you use the client for the things that can get thrown. One principle of that PSR was we need to have the client to have a defined behavior. Your library, your application, if it talks with a client, it needs to know what to expect. So, for example, some clients like Guzzle allow you to tell them, well, if there is a HTTP 400 or 500 response, please translate that into an exception. And the problem with that is for some applications, they may care about seeing these response codes, or maybe they don't. But if you would say there is always exceptions, you would have to have this kind of exception-driven coding. If we would say you can choose, then how would your library that you implement, how would it know what's going to happen? Or we would make the client interface super complicated and stateful and say, like, I want to send a request with exceptions or not with exceptions. So instead we said that the model is that your client is going to check the response codes and then translate bad responses into exceptions of your domain, which you want to do anyways. You don't want to handle HTTP level exceptions in your domain code. And the only thing that actually needs exceptions, because there is not going to be a response, are these two here, the request exception. So if your request is fundamentally invalid, it's not working, I don't know, you didn't set a host name, it's just an illegal request that cannot even be sent, then there is not going to be a response and you need to know about it. And the other thing that can happen is kind of more runtime problem where there was a DNS issue, connection error, connection interrupted, these kind of things. So I'd say the difference between these exceptions is the request exception probably means your code had a mistake. And the network exception probably means there was some problem in the network. You could potentially retry later and it might work if you try again a few seconds later or half an hour later or whatever. So it could be useful to distinguish these exceptions to know if you should retry or not. So then what about configuration? When you do HTTP requests, you could bother about the timeout settings, like how long do you wait for the server to reply until you abort the thing and say, well, there was no response? Or would you force HTTPS? How do you handle redirects? Do you want to know if you get redirected, or do you just want the client to handle that transparently? And in our opinion, that's not a decision for each endpoint, for each single thing that you write to do. So not a decision for each single request, but it's a thing to configure on the whole client. And then you inject the client set up the way you need it, and then your library that talks over HTTP can rely on the client to be set up correctly. There was discussion, should we have like maybe this array configuration options thing to pass in options like Guzzle does? The problem with that is we would suddenly make the standard define what options exist. And that raises the question, what about unknown options? Like what should the client do if it gets an option that it doesn't know about? Would it then just ignore it, or would it make an error? Or should we just limit what options can be passed, but that's of limited usefulness? And the problem there is if the library that you're writing would, for example, rely on the redirect to happen, but the client that actually is used doesn't know the option that it needs to redirect, so it doesn't redirect, so your client would still have to check, oh, did I get a 302? I have to actually redirect. So we said, let's keep it simple, let's keep it like a well-known behavior, and if you go with something like Guzzle, you can configure it, you can configure all this stuff as you need it and then inject that. And if, for example, you would need different behavior for different use cases, like for requests to one server, you need to send some authentication, you can inject more than one client into your library and say this is the client to use for the API that you have to authenticate against, and this other thing is the client to talk to the general internet if you have a request to something else, for example. So PSR-18 in reusable libraries. What you require, or what the library is going to require, is the implementation of the PSR. And this is a virtual package. Not sure who is familiar with virtual packages in Composer, who has used them, seen them. Okay. So the idea is it's like an interface in a way. You say, I want something of this type, but I'm not telling you a specific thing. And when you go on packages, you can search. That's quite small, I guess. So if I search for this PSR HTTP client implementation, it finds that, and then if I click it, it shows me a list of all the available implementations that implement this. So with this, I can then choose a client, and the user of this of the library that depends on the virtual package needs to choose one client. So there's like a little bit of additional thing you need when you cannot just require the library, but you also need to require one of the implementations of that HTTP PSR client to make it work. But the big upside here is if you're already using, for example, Guzzle, then you can just use this library that needs the PSR compatible client. If you're using something else, you can use that other client. You don't end up installing 2 versions of Guzzle plus some other HTTP clients as well. And then a library using PSR-18 usually would be injected the client instance and the request factory created by the user of the library. There's a thing to do AutoDiscovery. I'm going to talk about that a bit later. I'm not a big fan of it, but it exists and I think it does have its uses. Whoops. So what happened with the Qt Elephant and HTTP plug? Is it obsolete? Is it replaced by PSR-18? The main interface is replaced. We made the HTTP plug interface extend the PSR-18 interface so that you can have a smooth upgrade path. But then more important, we have a couple of adapters in this organization, for example, to use old versions of Guzzle as a PSR-18 client. Because Guzzle in the latest versions, they implement the PSR-18 interface themselves. But then with old versions of Guzzle, they can't. So there is a glue layer that uses Guzzle to provide a PSR-18 client. And then we also have a bunch of middleware for PSR-18 clients. So you can have a middleware that acts as the client and then goes to the actual PSR-18 client. And some convenience clients, gonna show them in a bit, and the AutoDiscovery. So the middleware thingy is the plugin client, where you can have a plugin that takes the request and gets the chance to interact either with the request or with the response coming back, and has a way of forwarding to the next plugin, or it has also a way to restart a chain to go back to the first item of the chain. For example, if you want to do a retry of the request, you could go to the first plugin again. And then there is a whole bunch of plugins that we already implemented for common tasks, like adding the host name to the request if there is no host name yet, where you would just say, like by default, if there isn't a host name, just add this host. Or adding a path or a path prefix, query defaults, where it checks is that query parameter set by the request. If not, I add it. Or all kind of header manipulation, where you remove headers, add headers, or replace them. There's authentication. I'm going to have a whole slide about that, because it's a bit more involved, can do a bit more. And then also utility things like setting the content length of your request, checking content types, decoding content, all these kind of things. And the nice thing about if you have these PSR-18 plugin, or how to say that, like if you use these HD plugins, it comes before the actual PSR-18 client, so it doesn't matter what implementation is used. Like all of these things exist, for example, in Guzzle as well, but then you would be tied again to use a Guzzle client because otherwise your thing wouldn't work the way you need it to. There is a cache plugin that takes a PSR6 cache and then can cache responses. And we make that configurable, like which cache control headers you want to respect or don't want to respect. That also depends on what your use case is. If your server is doing requests against some system with just like the credentials of the server, it probably feels more like it's a client to that other service. But if you're doing requests on behalf of the current user, maybe you're more of a proxy kind of way. So we actually made two constructor functions named constructors that would act for this case of a client where you say max age and no cache are the important instructions. And if you're this proxy case, server case, then for example, you shouldn't cache if something is private. But if you're a client, you can cache if it's private, but if you're a server, you can't. So you have to figure out what you are when you're doing caching. Then the authentication plugin takes an authentication service, which we implemented the obvious ones again, like basic authentication or bearer, WSSE. And then we also have like utility authentication that can, for example, depending on where the request is going, authenticate or not, or authenticate differently. And the plugin just changes the request to include the authentication. And then if you need a token that you get with a web request, you can inject another client instance into the authentication service. It shouldn't be the same client because otherwise you're ending up in an endless loop trying to get the token, coming back to your plugin, getting the token that goes back to the plugin. And then we have some other these convenience clients that you can give any PSR-18 client and they themselves are PSR-18 clients providing some additional functionality, like a round-robin client or least recently used, that takes a number of clients and it just goes to one of them. Another one is the HTTP client router, which you can configure with clients and request matchers to tell it if the request matches this, you use that client, otherwise you use this client. So that could be another way instead of, or how to internally handle these multiple clients for different use cases. You could wrap them into this router thingy to decide how to send your request through which client. There's also a batch client that can take a whole array of requests. So this one is not a PSR-18 client. It's just wrapping a PSR-18 client, but then batching the requests. Or a methods client if you prefer to have this quite simple way of, you don't even need a request factory here. You would do it like you used to do it with Guzzle, where you call a method get or post or put to a path and pass the things in the parameters, and then this client internally uses the PSR-18 to build the request and send it. And then the discovery. So this one, I'm a big fan of dependency injection, but for some situation or for ease of use, it can be nice to have this discovery way of things. So that's one repository, and it has a static method for each of the things that can be discovered, where you just tell, hey, I need a request factory, please. I don't care what it is, just find me one And for all the implementations that we know about, they're implemented in this factory method. So it goes and checks, how is this interface present, is that interface present? And the first one it finds that is available, it instantiates and gives it back to you. It can be a bit tricky sometimes because we noticed, like, sometimes there is things where you have one piece of the client present, but not actually all of it, because it's distributed over several repositories. And then if one thing is installed but not the other, we said, like, oh, we have this thing, and create it, and then it explodes because actually it's not completely there. But the nice thing about this is you have it like all wrapped together, and several people tested and worked on that. So you don't have to repeat the mistakes that we did when we started that. So basically, you could require this in your library or in your application. And what I strongly recommend, if you do that, is to still have, like, allow to inject instances and only use the discovery as a fallback, so that your users has a chance to say, well, I need this client to be set up in this and that way. I need to add some login plugins into the client. And if you just go to the factory, you deny that option. So this way you have the flexibility, but you also have the convenience of the consumer not having to instantiate a client if the consumer doesn't care how it's instantiated. We also have a Symfony Bundle for those who use Symfony, which allows you to configure PSR-18 clients or also the older HD plug clients, configure all the plugins on them. It integrates into the toolbar. And configuration would look something like this. So you could enable that methods client that I talked about before. You can set plugins. And important to note, this piece here, so you give it a name. You can define multiple clients as well with this. And then have all of these available as services and configured with the plugins. And then in your code, whatever, you can just use them the way you would usually use them. And if your request went through HD plug, you will get the toolbar will have this little elephant telling you what requests were done. And some people really went a long way to make the information page about the requests useful. So here you see what client was used. That's the gray app thing. And how many requests went there. If there would be others, you would see the others as well. And then you see, oh, it was a GET request to phpday.it. It took 67 milliseconds. It responded at 200. And then one really cool thing is below you have the curl line, which the aim is really that you can copy-paste that on the console and then repeat your request on a console. So if it failed, you could take that and try to tweak around, figure out why did it fail, tweak around, how can I fix it if I add this header or if I change the path here, does it work then? As a help to debug without having to rerun your PHP code if the problem really is your request not working. And then you also have you have all the headers of the request and of the response. And even if you use the HD plug plugin client, you get a list of the states of the request and response for each plugin. So you can see this header set plugin, it changed. Where is it on the request side? The other way around. The content length plugin on the request side on the left, it added this content length field. So you can really debug what was going on with the plugins. All right. So that's it for the PSR-18 and for the requests. I want to take a moment to talk about something I didn't really mention so far, which is asynchronous requests. So PSR-18 is completely synchronous. You call the method. When it returns, you get a response. It's ready to use. Your code doesn't have to, I don't know, wait for anything. But then there is the situation when you, for example, especially if you want to do multiple requests or have to do other things as well, it's very convenient to say, well, send this request, and then now I'm doing other things, and maybe at some point check if the request is ready, that the response to that request, or I'm just doing all my other things, and then I wait for the response to become available. And that way I can parallelize things. The big problem with that is you need some sort of construct to handle asynchronous, because what you get back from the client cannot be the response already. It needs to be something that eventually gives you the response. And the concept commonly used for that is called promises. And a promise is just the thing saying, well, in this thing you're going to have your response eventually, but maybe not now, not yet. And then the promise has a method called wait on it, which you use when you say, well, now I need my response, so I wait for it, for the request to resolve so I can get my response. So it would be nice to have a PSR that defines that as well, but to do that, we need some sort of promise implementation, and the PSR about HTTP clients definitely is not the place to define how promises in general work. There is something very much like promises in PHP 8.1, the fibers. So I do have hopes that now we can move forward with this topic, that we don't even need a PSR for promises, because fibers should be able to handle what we need here. So fibers basically are functions that can be suspended. So you can call the function, and then it can suspend itself and return control to the caller, and the caller can continue, and then kind of communicate with that function. What it is not is, it's not threads. So you cannot, when I first read about it, I thought, oh cool, so we don't need to do anything. You can just start this fiber, have it do the web request, and then eventually have the response, and the main code can talk with the fiber to get the response. But the problem is, if you do a blocking call inside a fiber, your PHP process is still blocked. It's not going to continue. So you need to use non-blocking things, like non-blocking I/O, non-blocking web requests. But React PHP adopted fibers already, so they already implemented asynchronous HTTP requests with fibers, and they're also working on a React adapter for the HTTP plug ecosystem. So we will see. I think that will lead to a solution for this. So if you do this asynchronous way of HTTP requests, it will be, so maybe to mention, in HD plug, we implemented all of that, including the promises, because it was this kind of abstraction library. We said, let's try it, let's build it. But it's not a PSR, it's just an implementation. Basically, when you have a promise, you can give it another callable that it should call once it resolves. You can check on the promise what its state is at the moment to know, is it still unfinished, or is it finished, or did it fail, basically. Then it's rejected. And the call I showed before, you can wait on the promise to resolve. And the wait method will return you either the result or it will throw an exception if it failed. So with promises, what you do is you would loop over your things. So here I'm just having an array of URLs, and I send async requests to these URLs and collect the promises that I get back. And then in a second loop, after I fired off all these requests and have the promises, I can loop over my promises. And here I'm simply building a string that shows for each of these requests if it got a 200 response or not. And when you look at it, I'm just looping over this, doing the request, and then looping over the other and waiting for the responses. But the important thing to understand is that once I did this send async request, the client implementation is doing a request in the background, because the way this is done, for example, in Guzzle, is relying on curl implementation, which in turn actually does use threads. So suddenly you're like moving the blocking thing out of the PHP execution. So when we start in this loop, all the 10 or however many requests we have, they're currently running or maybe already resolved. And then we wait for the first one, and even if that one takes a long time, maybe the other requests that we had have finished meanwhile. And then when we wait on the others, they're already finished, so the response is there immediately. Or instead of keeping the promises and calling them, we could make that the request, get a promise, and then have a callback function for the success case that looks at the response and does something, and another callback for the failure case, and then call promise then to make it, to connect these functions, and then the promise is going to call one of these functions depending on the outcome. And then in the end, we still have to wait for the promises to resolve so that we are sure that all of that gets executed. And once that's all executed, we will have the results, which we have in the callbacks. So the result is passed into the callback. The callbacks fill the result array, and then our calling code can access all the results there. All right, and that's it from me.
All right. Don't forget to rate the talks on Joined-in, also the previous ones. Do you have any questions for David? So we had one actually from the online audience, and was about subclients. Like, can you implement subclients with an underlying PSR-18 client? I guess the answer is yes.
Sorry, soft clients?
SOP.
SOAP?
Yeah, SOP.
Oh,
I guess the answer is yes, right?
I don't think so, because SOAP is not
yeah,
HTTP.
exactly. You could put a PSR-18 client inside a SOAP implementation just to handle the HTTP calls, right?
Oh, okay, yes,
yeah.
yes, but
exactly.
I wouldn't really see the point, because then you would still pass what you want as a HTTP request, and then translate that into a SOAP call. I don't think it's necessary.
Mm-hmm.
If I use a SOAP service, I would write my own wrapper that makes a nice PHP method on it, where I can say, like, I want this, get ID, get the product with this ID, and it does the SOAP call directly. I don't think I would wrap it with PSR-18.
Yeah, maybe just to handle the HTTP traffic.
Yep.
Maybe just that. Yeah, okay. All right, so time for a coffee break.